which you created your own CDS view. So model and retrieve data on a semantic level higher than the SQL. Extends native SQL means for increased productivity. Then we have the query language, the consume CDS entities via OpenSQL in ABAP, fully transparent SQL extensions. So you can normally write logic, guys, like, what do we mean by open SQL statements is select statements. You can write the select statements on CDS views, and you can use it as a normal view, just like we used to use a normal view. In that way, we can use it as a table. The define authorizations for CDS views. What you can do is you can have a control over who has to access the data and who should not. So those type of controls will have this. We have this, and define authorizations for CDS views. Model and declarative approach, so integrates with the classic authorization concepts. So we have integrates with classic authorization concepts. So classic authorization concepts in the sense, like, who can access the data, who can read the data, who can delete the data or modify the data, who can create the data. All these things we can create the authorizations in the DCL. So we'll have DCL code also we will write, guys. Like, I'll just show you how to write that. Anyways, query language we already know. We are done it in a select statement. But the only thing is, here if we are writing the select statement, we are just writing in what you call we are using the commas and all. So that is an SQL code that we have select statement. Now here we have in core data services, ABAP allow define semantically rich data models. Okay, so we have ABAP language, OpenSQL, ABAP dictionary. So we have DDL, data definition source, and DCL, data control source. These are something which we have in the part of ABAP core data services. Any other database? So SAP HANA database, we have in SAP HANA database, we have core data services, we have SQL engine, we have calculation engine, we have SQL script, we have data definition language here as well, and we have the query language as well. So we are writing at the database level. Normally what happens in the ABAP language, in normal ABAP language, we have ABAP dictionary. In ABAP dictionary we are going to do the DDL. So SE11 happens to be our DDL source. We cannot create a table by writing some ABAP code. So DCL, data control language, also we are going to do it at the dictionary level only. Then OpenSQL statements are only for this the query language, the data manipulation language, DML. So DML is nothing but the query language. So we have ABAP language. So any database, any other database is there. From that, if you want to get the data also, we have ABAP CDS provides read access to data only. So we have SAP HANA database. So from here we are actually accessing the data, and we are showing it on the screen. So this is what we have. So CDS views provides read access only. Okay. So we are not manipulating the data. We are just reading the data using the CDS views. Now the benefits of CDS views compared to ABAP dictionary views. So we have done the normal views also, and we have done the CDS views also. So in the CDS views, what exactly happens is we can go ahead with the inner join, outer join, union, association. So there are a lot of other advantages of going ahead with the CDS views, which we are going to do in the coming examples. And then we have what calculations, aggregations, expressions, grouping, all these are not possible at the ABAP dictionary level. And then nested views. So view inside a view is not possible in the in the normal views. Okay, you cannot create a view again with other views. Okay, you have to take tables only. So here you can create a CDS view, and that CDS view again can be consumed in another CDS view. Then we have SAP specific. So SAP HANA column views. We have the complexity over and features. So we have CDS associations, ABAP 7.4 Service Pack 5. So we have previously we used to have SE11. Okay, in SE11 we used to create all our database tables. CDS view definition, we are going to create it on the tables. Then we have view definition, SQL 92, and we have SAP HANA column views. So column views, what are the column views? We're going to see that. So these column views are specific to SAP HANA. Okay, this column views cannot be seen in the normal ABAP login. So basic CDS views definition. So basic CDS view definition, we already have done it. So define view, and this is a view name as, so this is a SQL view name, and this is a view name. So SQL view name it should be different than the view name. So we have written this select star from sbook. Okay, simple logic. Here, instead of select star, we have written this define view as select. Now what we can do is we can use the alias names, guys. So in the report, in the output, if you want carried to be displayed as airline on the board, on the heading you want it as airline, then you can just go ahead and say carried as airline, carried as flight number, uh, filled it as a flight date. So in this way we can do alias names, we can change the alias names, and that's one thing we can do. So we can rename the columns. Okay. And then alternative syntax. Alternative syntax in the sense, like we can have either like this, we can write it like this, or we can write it in the flower brackets. So we prefer to write in flower brackets so that we know what are the fields that we have. Select from sbook. So we have this. So either we can write select these fields from sbook, or we can write select from sbook these fields. So select from sbook, if you write first, you have to write the flower brackets here. This is what we have. And let's see this in the system. Okay, so here we have this VBAK. Okay, A is change date, change name, as some description or something like that, as some text. Okay, so we can do it like this, and then we can just go ahead with the save. Okay, activate, and once it's been activated, we can just see the data. So when you see the output, we can see that the change date, change name, description text, whatever we are given it as a text, is coming here. This is what we have. Okay, so this is what we have here. So this is what we were discussing about. Okay, so these are the alias names that we can give. Now, use of annotations in CDS views. So annotations, what we can do is we can use some annotations. So enrich CDS data models with additional metadata. Annotations begin with @. So different ABAP specific information can be added. Name of the associated SQL ABAP. So name of the associated SQL ABAP dictionary view, mandatory. So this is the dictionary view, dictionary table. So the S book is mandatory. We can do the buffering. We can select whether it should be buffered or not buffered. And then what we can do is we can make it, we can make sure that it is client dependent or client independent. So default is client dependent. So reference information for amount and quantity columns. So what we have here is, like, we have semantics amount dot currency code currency, and then we have semantics currency code currency. So for amount, as we all know, if you have an amount, for amount currency is mandatory. So we have local currency and local amount. Then we have this for amount currency code, we have currency. So what are we doing is we are telling to the system that, for amount, the currency code is currency. And where is this currency defined? Here we have defined it here. So currency. So here itself we are whatever field is there, that field we are keeping it here, and we are saying that this is the field which will actually define the currency. As we all know, like, if you have, if you're saying the amount as some number, if I'm saying it as 100, what is 100? 100 does not have any value unless and until we have you know uh, we tell the currency. So currency is very important. So we have select list support for expressions in CDS views. So we have this we can go ahead with this kind of a strings and arithmetic expressions we can write in the CDS views. We can go for the cast expression, and we can go for case expression, and special built-in functions also we can make use of that, like coalesce is something which we can make use of in the defining the view, the CDS view. So you can say in select statement itself, we can write like this: select from sbook carried conned as a flight number. Okay, we are saying concatenate carried and conned. These two we are concatenate as flight number. So we are concatenating the flight name and the flight number both as flight number. So FL date and book carried. So FL date book ID are the next fields actually. So then we are concatenating. Then we are concatenating substring order date 5 2 and hyphen. So what are we doing here is we are actually manipulating the data. Is order underscore date is a field. In that we are picking up the 5 and 2, and that we are adding up the hyphen. So order date 1 comma 4 as order month. So it's picking up the 1 and 4 and it's taking it as a order month. So within the select statement, okay, within the select statement again we can write case in case also. So in case we don't have case in case, we have case and that's end as case smoker, end as adjusted amount. So when x, then cast as this one, and else cast as this one. So this is what we have. So we are writing a condition here, we're checking the condition, and then according to that we are, and the case in case what we have is in normal ABAP we have case, we'll say others. So instead of else we'll go for others. So here we have else and we are putting a condition again here. Okay, so currency conversion. So this currency conversion is like, amount. We can we have the local currency, then we have source currency, we have target currency. These all for these all we are doing the currency conversion. So cast EUR as above currency key. So exchange rate date order underscore date. So these are the currency conversions which we can which we can do it on the system. Okay, support for joins where aggregations, grouping, and filtering is in CDS views are done. So, like in OpenSQL, we have joins supported with inner join, left outer join, right outer join. So these are the things that you can just explore, guys. Different types of joins. So, anyways, if you want, I can share that video with you. So you'll get it. You'll get the information about the types of joins if you just type it in Google. So there'll be inner join, outer join, left outer join, right outer join. So we have equi join. So there are many types of joins. So here, SQL CDS views support inner join, left outer join, right outer join. So here, if you see, here we have this. We have inner join. Okay, we can also go for outer join. So before or after the field list. So no select star together with joins. So we are giving this field, we are joining two tables, and then we are writing. In this we have written the field names, but here we are saying sum book local currency. So it's we are making a sum of it, okay, as total amount, and max book local currency max underscore amount. So in this way we are having this sum, max, minimum. These are keywords, guys. So it's the minimum value, this is the maximum value, and this is the sum, where we can put the condition here after the flower brackets have been closed, where customer dot country is equals to US. This is a condition. Group by book dot carried comma book dot local currency. So where so these are the conditions. And group by means we just collecting the data with this book dot carried book dot local currency, having some book dot local currency greater than 100. So these are the things that we have. So these all conditions can be written and you made use of in the CDS use. Then we have the unions. So we can go for unions. Unions is a combination of all. It combines everything. Combines everything into it. So right now we have select from S custom. So in S custom ID, form, name, street, postal code, city, country, postal code, customer type, where postal code is not equal to space. So this is one condition. In this condition, there will be some fields that get selected. Okay, what is the condition here? Postbox is not null, and the second thing is customer type is B. So in the first query, we have a condition that postbox should not be null, and second condition we have customer type B. So these two values combined together will be shown in the one view. So column lists of queries must have equal number of columns, be of compatible types and in matching order. So union can be possible only when you have same fields in the same order. If you have id, form, name, everything will be in the same order. Okay, if you have postal code before and country later, then also it will not be possible. So union implies an distinct semantic. Union all does not include distinct. So ABAP CDS views on database. So we have this ABAP dictionary and database object correspond to active ABAP CDS views. So we have this create a view. We have HA400. So this is something which, if you see the attributes in this, like we can see when you click on this, you can see the code, actually the entire code. So ABAP CDS views on database. So we can we already done that. We went into the SE11 and checked this the SQL view name. So SQL view name we typed there and we have seen that. So in that, if you keep the cursor there, then you can see the code below that. So what is the code that already been got executed by default. Now, since if you might have observed, these are the things that we have discussed earlier also, but since you have worked upon the CDS view now, you'll get more clarity. So you can relate this what we are discussing right now to the previous projects that you have done just now. So selecting data using CDS views, we have using CDS view name in from clause in OpenSQL, like any ABAP dictionary view. So CDS views can be client dependent, but don't contain a client column. So query data from other clients using the using client clause. So we'll generally don't see that client field name, but it is always client dependent. Okay, and we have select star. So selecting data using CDS views. So we can write like this. So since you already created a CDS view, so we can write like this: data LT underscore orders types and a table of this H400 underscore DL underscore HP3. So this is your CDS view, guys. So this is the CDS view that you have created, and select star from that CDS view into table LT underscore orders where customer is equals to 931. This is what we have. And select start from H400 DDL SB3 using client 111 into table LT underscore orders where customer is equal to 931. So we have 111 here using client 111. So we can mention the client. Even if you don't mention the client, it is always client dependent. The selection is always client dependent. So we can assume that particular CDS view which we have written as a table, and then we can extract the data from it into the internal table. Now core data services enhancements. So what we can do is, you can enhance CDS views with table columns. You can add few more columns to the existing table. Let's say somebody has already created a CDS view without touching that code. So, irrespective of where that code is there. Okay, so we don't know where that code is there. It's created, then done. Now you can write a logic and add some fields to the existing CDS view. So for that we can write like this. This is the code. This is the view name. Extend view HA400 underscore DDL SB3 with H400 underscore DDL EX underscore SB3. So this is the view with extended fields. HA400 underscore DDL EX underscore SB3 is the file with extended fields. So we have concat carried conid as flight number, order date, case reserved when X, then reserved book else. So these are the conditions, guys. So this is an extension view. So we are extending the view here. For extending view, we can go ahead with this, like this kind of code, extend view with this one. Concatenate order date, case end as reserved. So these are the CDS associations concept. So define relationships, easy to read and easy to use. So we have target entity and optional alias. We have cardinality optional. So cardinality in the sense, like we'll have cardinality 1:1, 1:n, n is to 1 or 0 is to 1, 0 is to n. There'll be multiple cardinalities. So here couple of cardinalities will be accepted. So we have a target entity with optional alias, cardinality optional. So on condition represents join condition. So easy to refactor. Consumption as usual in projection list, aggregations, so where group by and having clauses will be there. So we have this select from sbook as book. Okay, select from sbook as book. Now here we are giving the alias name for the table name. Sbook is been renamed as book. Association 1 to S custom as customer on book.custom id is equals to customer.id. Book.carried, book.local currency as currency code, sum book.local currency as total amount. So these are the conditions. So we are writing this book.local local currency key. This is book is what? It's the alias name. Okay guys, see, you don't want to write the big letters of big name of the table. You can just use the alias name. Okay, we can just use the alias name. So we have this. So here we'll just go for this one as SAL2 because that was already existing. So we'll make it as SAL2. Now what I'm trying to tell you here is like, here we can say from VBAK as A, okay, and VBAP as B. So you don't have to write every time VBAK and VBAP. So we can just say A dot VBLN, okay, B dot VBLN, okay, and you don't have to write all this A again and again. You don't have to write VBAK A A B B. So these are the things that we have. Okay, so say okay, activate, and this works absolutely fine with all this. So we can just execute. So we'll get this data. Okay, and as we know, we can use the alias name as sales order number, and then we have as created date, as created by, as say that some organization, as MAT number, middle number, and we can, so these will be the headings in the output. So we have this. So we'll have this sales order number, created date, created by, organ, material. So these are the values that we have. Now here these are the values which we have. Guys, it was very important for us to do those stuff, like, so that we can understand more better about all this stuff. So here we have association. In association, what happens is, its association is something similar to join with slight changes. Okay, so association, we are going to just say how many fields we want to extract, one to one, one to many. Based on the cardinality, we can join the data and we can get the data. So if you want only one record for one value, 1:1, then we can also get it in the association. So association has some advantages, guys. Like, when we go for association, we'll have a couple of advantages. So instead of inner join, we are going to go for the association. In association, here we are doing one. One means what? Equivalent association, using association. So in equivalent association, what will happen is only one record will be extracted for one value, one header value. This is what we have. Okay, so we have ad hoc association defined and used in same CDS view join. So we have ad hoc association defined. So in this, like, we are defining the association and customer dot name, customer dot cust type. Then we have book dot customer ID here. It's a prerequisite for exposed association. So book dot custom ID. We have this book dot custom ID is the one on which we are joining this to. Okay, and customer, where book dot cancelled is equals to this one. So we have this prerequisite managed. So association types, will just do one simple example, okay, so that you can understand this association type better. So this association type will be nothing but, here it will be there. So when we were creating this series view, here set va underscore ASSOC association. So here we can select the association here. Yes. So here we'll have association, define view with association. Then we have define view with parameters. Parameters in the sense, we can give values, according to that values only we can get the data. So extended view, we have extended view, we have define table functions with parameters, define abstract entity, and we define abstract entity with parameters. These are the options that we have. So we're going to discuss them theoretically, and then we can do it on the system. Okay. So these are things that we are actually discussing here. So we have the association types. In the association types, we have ad hoc association. Ad hoc association defined and used in the same CDS view. This is the join. And then we have exposed association, in which, like, we have defining CDS views exposes associated entity generically. So instead of writing this customer.id, we are writing directly customer. So in association, we can write like that instead of that field name. So where book dot cancelled is equal to something. So book dot cancelled something is the condition that under which for which we are getting the values. Okay, so we have using exposed addition. So using exposed addition, we have this follow association. So in this, like, we'll write like this: define view, select from this thing, carried currency code. These are two different fields. Sum is another field as total amount, and then we have customer dot region and customer dot discount. So now if you see, customer dot region, customer dot discount are not there here. But what are we doing is, we are where customer dot country is equal to US group by carried and carried. Now here this HA400 underscore DDL underscore SBC2 is the previous one. See, in this we already have this customer is already there in this. So this view we are consuming in the another view, in the second view, next view. This is used exposed association. So now what we are doing here is, we are making use of the fields which were used in the previous association. Now consuming associations in OpenSCale. So we can consume the associations in the OpenSCale. whatever associations we have used in the DB's SBC2, that can be used in some other select statement. Now this select from, we are considering this as a table. Fields, these are the fields that we have, and into table LT underscore customer. So LT underscore customer is the internal table to which we are selecting all these fields. Then we have the filtered association. So in the filtered association, define association of cardinality 0 to n. Okay, so we have this for filtered associations. In the filtered associations, again we have when class is equals to C, class is equals to Y, class is equals to F. So again, within that association bookings, we can write this condition, like, when bookings is equals to, when in bookings, when class is equals to C as business flights, bookings when class is equals to Y as economy. So what are we doing? We are analyzing the data here itself. See, so bookings is a single field, guys. So when the bookings happen to be C, type C, when bookings value is C, we are making it as business flights, and then we have economy flights, and then we are making this as first class flights. So we are filtering them into three different categories based on this one single field. This is something which we have filtering, and cardinality can be used. So we have 1 is to FL date. So only one single value for FL date 2015-0101. Even if you have more number of records for this FL date, you will not get it. Only one value will get it. So defining a serious view with input parameters. Serious views with input parameters. These are the values that we have. Comma separated list for of scalar input parameters with type. So parameter types predefined or data element. So parameters can be used in projection list as element or in expression. So on conditions of joins, expressions in where or having clauses. So these are the things that we have. So in this, like, we can have this comma separated list of scalar input parameters with type. So here what we have is 15 comma 2 means what we have is the ABAP dot currency, which will have this 15 length and 2 decimals. So these are the things that we can have. The length can be defined in this way. So parameters can be either predefined or data element. Okay, we can also give the data element as well. Then we have the projection list as element or in the expression. So we can put an expression here, local currency into, this is smoker dot factor is a parameter. So smoker dot factor is a parameter, so we are mentioning it here, and dynamically we are mentioning it as a parameter, and then this is also a parameter and as adjusted amount. So these are the things that we have. So using input parameters in path expressions. Using input parameters can be used in filter expressions, can make exposed associations more helpful. So using additional views with filter in path expression. So what we have here is, in this, like, so we can make exposed association more helpful. So what happens is, what is an exposed association, which we have already done, that we are using it here. So if there is an exposed association, define view this one as select from S customer as S customer. So this is something like SCFL. This SCF1, whatever this association we have done, we are using in the below one. Okay, define view H400 DDL SFCI. So SFC1 we are using in SFCI. So in this, with parameters FL date app dates. So what are we doing here is, we are restricting the data based on input parameters. Okay, we can do a couple of examples in this one as well. So serious input parameters default to system fields. So we have, these are the system fields. So a couple of fields we can make use of in the parameters. So we have sy langu. When sy langu is equal to so and so, only then extract the data. Sy uname is equal to so and so, extract data. So something like that. So we can put these conditions here. using a CDS view with input parameters in as a CDS view. So consume CDS view with input parameters in other CDS views. So we have one CDS view can be used in another CDS view with input parameters. So FL date is equals to 2015-0101. So consume CDS view with input parameters in order in open SQL. So we have this. This is another condition when we have the parameters in input SQL. Using CDS view with input parameters in ABAP 7.4. So what we have is here again we have a few more options here which we need to go through slowly one by one, guys. So enhanced OpenSQL versus CDS views. So enhanced OpenSQL programs are something which we are doing in the normal ABAP, and then we have the CDS views. So CDS views can be used only in ABAP and new SQL, no new OpenSQL. So use OpenSQL if you need query in one piece of code only, need features only available in the OpenSQL, such as for all entries and all. Now in the CDS views, we can have a reuse case similar as a dictionary views. So we can again and again use a CDS view. Okay, we can create a CDS view and we can use it in another CDS view. Those are possible in the CDS views. Now this is a DCL, guys. DCL code. DCL means data control language. So now what we are doing is here is we are writing a classic authority checks on instance level. So we have authority checks. We have authority checks is now here we have this loop at this thing. So authority check object s underscore carried. Now here what we are doing is s underscore carried. Only when it is s underscore carried, then we are an ID carried and ID activity, then we are going for authority check. So we are saying delete LT underscore customer index SY topics. So this comes under the DCL data control language, in which we have a select from this table. That's a view actually. Fields carried conned some local currency, and then we have currency code, customer postcode, and customer city, customer street. So where carried is equals to LH and customer country is equals to US. Order by carried, conned, currency code, customer postcode, and then we have into table LT underscore customer. So loop at LT underscore customer into LS underscore customer. So we have this authority check. So this authority check. So when we make this authority check, user are not. So it will say authority check if S underscore carried and ID carried field ls underscore customer underscore carried ID activity field 03. So only when these are satisfied, it will loop the data. I mean, it will delete the data. So delete ls underscore lt underscore customer index sy topic. So if you want to delete, so user not authorized to see current line. So we will be able to delete only when we have this condition satisfied. Now here we have, this is called data control language, DCL. So models authorization based on CDS views. So we have defined role. So this is a DCL. Okay, so access controls. Now here when we used DCL, DDL, right? So now we will be using DCL. So this option will be there here. In the core data services, we'll have this option here. Access control, we have access control language. So we were using data definition language. Now we have access control language. So access control is something where we have this DCL comes into picture. This is what we have. Okay, this is the access control language. So when we use this access control language, we can do this define role and the view name grant select on HF400 underscore DDL underscore SBC2. So when we write this, where carried is equals to aspect PFCG underscore authorization S underscore carried activity and 03. So in this, what we are doing here is we are doing the defined role. Then we have grant select on this one. So when we write this grant select, we will be able to access the data from it. See, initially when you write the select statement on the on a view that we have created just now, the CDS view, it will not work. So but when it comes to what you call when we write this logic and then we make use of this select statement, then it will work. Okay, so just now you created a CDS view, right? So directly if you use this select statement, it will not work. So when we have to have grant select on this thing. Okay, so here we have literal and aspect conditions. So if you have literal conditions, allows declaring new authorizations. So we have country is equals to US, can be combined with aspects of condition. So we have this defined role name, grant access on this one, where country is equals to US. Only for country US we are granting the role. So people can access only the data which is of equivalent to country US. Then we have aspect conditions for aspect PFCG. So allows reusing existing authorizations. So we have this PFCG or carried is equals to aspect PFCG underscore authorization. Aspect PFCG underscore authorization is a standard. It's a code actually. Aspect PFCG underscore authorization is a code. Okay, so these are the things that we have. So parameters, we are doing the parameters, guys. So we are checking the parameters and all. Okay, so now, why I'm saying all these codes and why I'm explaining this after you doing the basic CDS views is because you'll get a basic idea of what we are discussing about. So now I guess like you all got an idea about what we are discussing about. So we have annotations in DCL courses and we have annotations in DDL courses. So basic features of ADBC. Now, what are ADBCs? ADBC stands for ABAP database connectivity. ABAP database connectivity. So anything like which we use for ABAP database connectivity. In this ABAP application programming interfaces for native SQL calls will be there. So we have object-based, flexible, supports error handling, supports where use list, recommended instead of older execution SQL statements. So main classes are CL underscore SQL underscore connection, CL underscore SQL underscore statement, CL underscore SQL underscore result underscore set. These are the main classes that we are going to make use of in the ADBC, ABAP database connectivity. So we will be connecting to the uh, ABAP database. Okay, so ABAP database connectivity, and we have this. See, let's say we have native SQL, and then here we have DB for ABAP. So this is the other database. This is the ABAP database. So in this case, what are we doing is we can get connected to this, making use of this ABAP database connectivity. Okay. So in this coding example, so the ABAP database connectivity ADBC, we have this is the logic that we have in which like we'll be using the DB connection. So DB connection will be writing like this: create object LO underscore SQL exporting con underscore reference CL underscore SQL underscore connection implies get underscore connection HANA DB. So what are we doing here? We are using the CL underscore SQL underscore connection. We are using it. CL underscore SQL underscore connection get connection to HANA DB. So now here what are we doing is we are actually getting connected to the HANA database from the ABAP perspective. Concatenate select start from SFlight where MNDT is equals to something. Get reference of LT flight into LR flight. So this is the main thing, guys. So create statement object and DB connection in the is necessary. So if it is necessary, we'll go for DB connection. I guess like ADBCs, we just need to do one or two scenarios so that we can understand easily. But I'll just make you I'll walk through this ADBC concept. ABAP database connectivity. So when we are using ABAP database connectivity, we'll have no syntax check and at compile runtime. So handle exceptions CX underscore SQL underscore exception. So here we have this CL underscore SQL underscore connection, CL underscore SQL underscore statement, CL underscore SQL underscore result underscore set are the main classes. Then we have this CL underscore SQL underscore exception is the exception class. Now developer is responsible for client handling, specify client explicitly in where clauses, join conditions, accessing correct database schema, releasing database resources, example result set, proper locking and commit handling, database transactions. So ABAP table buffers are bypassed. So we'll have this handle exceptions in CX underscore SQL underscore exception. Then we have developer is responsible for client handling, where clauses and all, access correct database schema, and releasing database sources. So we need to understand more about the ADBCs, guys. So, ABAP database connectivity. So native SQL in ABAP. So we can have this native SQL in ABAP. So let's see the classical example of this. So classical OpenSQL and native SQL. So classical OpenSQL, we never used to have commas here. Remember? So we never used to have commas here, and here we'll have a commas between the fields from, and then after the from, then we are giving this native SQL statement. Then if we have a schema based table, so we'll write the schema name dot SPFLI. That's the reason, you all know what is a schema based table also, because you have done a schema based table. So what is that you have to go, we are going to give here? You're going to give the schema name dot that table name which you have created, okay, where carried is equals to LH and MNDT is equals to F. So MNDT is ordered by carried. So when we are basically doing a coding in the native SQL, we need to make sure that we have, we have the schema name dot the table name. So this is how we are going to connect to the HANA database. And then we have to write the MNDT as SYMNDT, because here automatically, even if you're not mentioning the client, it assumes the client as whatever default client is there. But here you have to mention the client ordered by carried and coded. So when we have joins in OpenSQL and native SQL. So joins, how we use joins in the OpenSQL, and how we use the joins in native SQL, which we are using in the database. So why are we using native SQL? Because native SQL puts more load on the database. OpenSQL actually operates in the application server. Native SQL actually gets executed in the database server. So now in this classical OpenSQL, we have b tilt carried, a tilt char name, b tilt conid, b tilt city from B till city 2. So from SCAR as an inner join, SPFLI as B. So this is how we write the inner join condition in our normal SQL program. So in native SQL, we'll write like this: B dot carried, B dot connet, A dot carry carnet, B dot city form, B dot city 2 from this one. This is a schema based table. So whenever you see like this, you can easily understand it's a schema based table, guys. So as inner join, and then we have rep zme dot spfli. Spfli is another table, scar is one table, spfli is another table as B. So instead of writing this big, that much big name, that schema name dot the table name, we'll just write as A, and inner join this one as B. In this, as we are writing in the bracket, on A dot carried is equals to B dot carried, and A dot emended is equals to B dot emended. Okay, this is how we are writing. So this is a classical OpenSQL statement. This is the native SQL statements. No automatic client handling. Client is just a key field. Now SQL console, we have already done the SQL console. In the SQL console, we went and we created the schema. So we didn't write the select statement and all in the SQL console. We just created schema. Create schema is what we have done, right? So there we can write the logic like this. So in the SQL, we can write the logic like this. So using stored procedures in ABAP less than 7.4. So in less than 7.4 version, the executing this execution SQL. So execute procedure DBP procedure. So this is a standard one actually. Then we're going to discuss about this ABAP stored procedures once again, guys. Stored procedures is something which we'll discuss later. So then we have, those are the ABAP stored procedures, and we have the ABAP database connectivity. Then we have ABAP managed database procedures. ABAP managed database procedures will actually work on the system directly, on the database directly. So ABAP managed database procedures also we'll discuss once again. So this we have already done. Basically, in the catalog, we went and we created a schema. Then we search for the tables. Okay, so we search for the tables and we added them in the. We have this. So this is an attribute view. We have to create an attribute view, analytical view, currency conversions, graphical So these all things we'll do it, guys. Okay, let's see. We'll see a few more examples in the next coming session. So this ALVs and all, ALVs optimized for groups concept. So this is a ALV which is optimized for HANA. ALV optimized for HANA. So this is how it looks like. So we have CL underscore GU underscore customer underscore container, which we already used in the OOP ALB. Then we have LO underscore SALB type reference to if SALB underscore GU underscore table IDA. This table IDA is something which is an SAP standard interface. Okay, and then we are going to use this create container instance. So we have create object, we're writing this, and we just get the data from S custom. So this is a simple ALB. Okay, we'll see this. Okay, it's like we'll go further and we'll discuss about these things in the coming sessions. Okay, so fine. And how about the UI5 Fury? Actually, for UI5 Fury, we need another server. I'll just try to get that. So once we get that, we'll be able to see a couple of examples in UI5 Fury. So we have something called UI5 Fury, and we have something called workflow. Workflow, UI5 Fury, these two things are very important. And we have something called debugging. Debugging concept also we have to discuss.
Sir, Hello, sir.
Okay, Kiran Aris. Yeah, I'm giving the access to Kiran Aris.
Sir,
Yeah. What's the issue here? Activation for this. Not getting activated. Yeah, you have it now. ZPR underscore CDS1 is not yours, right? Okay.
Sir, can I do next, sir?
Who's this?
Kushal, sir.
Kushal, I'm giving you. One second.
So,
Yeah, yeah, done right.
so if I execute, if the data is not available, sir,
I think PDTK VTP does
or
not have data. I guess I'm not sure. Maybe that might be the
okay,
reason.
sir.
But your procedure and all is correct. Perfect.
Okay, sir.
Yeah.
Yes, sir. You can take back the access, sir.
Okay. Who's next?
Can I do,
Yeah. Who's this? Pawan, right?
Pawan?
One second.
Sir, done.
Okay, Pawan. Done. Okay. Guys, if anybody wants to do more practice or something like that, I'll be coming back online at 7:30. If anybody is interested to again log in and do something, it's up to you. If out of interest, if you do it, you can do it. Okay.